The conductivity of carbon oxysulfide is OCS, right? A Lewis structure for carbon oxysulfide that satisfies the octet rule. Okay, so the first thing we do is we have to know the number of valence electrons. So OCS, oxygen, you have 1 times 6. Carbon, you have 1 times 4. And sulfur, you have 1 times 6. This is 6, this is 4, this is 6. Therefore, the total number of valence electrons in the structure is 16. 16 valence electrons. Okay, so we start with the middle central atom, carbon, then single bond sulfur, and then single bond oxygen. Next, we complete the octets, starting with the outside electrons, and then the last one would be the central. So let's start with oxygen. 2, 4, 6, and sulfur. 2, 4, 6. So we have 8 around sulfur, we have 8 around oxygen. And how many electrons have we used up so far? 8, 16. We've used up the valence electrons already, but we don't have an octet around carbon, so that's when we start doing multiple bonds. So this is not good. So let's try a double bond between carbon and oxygen. So carbon, double bond oxygen, 2 lone pairs instead of 3 because of the double bond, and then sulfur. Okay, we have 2, 4, 6, 8, 10, 12, 14, 16. We do have an octet on oxygen, an octet on sulfur, but we still don't have an octet on carbon. It's still 6, so it's not good. So next I'm going to form a double bond between sulfur and carbon. Carbon, oxygen, double bond sulfur, 16 valence electrons, 8 around oxygen, 8 around carbon, 8 around sulfur, so therefore that is a valid Lewis structure. Okay, so that will be A. B, what is the molecular geometry according to VSEPR? So we focus on the central atom. The molecular geometry, so to determine the molecular geometry, you determine the number of domains around the central atom. So around the central atom, we have double bond oxygen, double bond sulfur. A domain could be a single bond, a double bond, a triple bond, or a lone pair. So that's one, and that's another one. So 2 domains. Yeah, 2 domains, and they're both bonding domains. Yeah, so therefore linear. 2 bonds, 0 lone pair, so therefore 2 bonds, 0 lone pairs. So therefore our molecular geometry is linear. Okay, let's do question C. Does carbon oxysulfide have a dipole moment? Okay, a dipole moment exists if one section is more negative and one section is more positive. So oxygen, double bond carbon, double bond sulfur. Between oxygen and carbon, which is more electronegative? Oxygen is a lot more electronegative than carbon, yes? Next, between carbon and sulfur, which is more electronegative? It's sulfur, but the difference is not that great, so it's tiny. So notice that the left arrow is larger than the right arrow because sulfur is less electronegative than oxygen. So therefore we have a net force going to the left, meaning it's more negative on the oxygen side, so therefore yes, a dipole moment exists. Dipole moment exists. In what direction? In the direction that is going towards oxygen. Okay,